good evening to all the participants. And Center of Excellence in Safety Engineering and Analytics, IIT Kharagpur, welcomes all the participants to the weekend talk on safety engineering management and analytics. So this program is conducted under Azadi Ka Amrit Mahotsav, Government of India initiative commemorating 75 years of India's independence. So today is Dashera, and let's pledge to burn our top 10 behaviors for unsafe acts, and like the feeling like nothing will happen to me, or neglecting the risks of near misses, not following process and procedures. So we start our program with this wonderful shloka, Asato ma satgamaya, tamaso ma jyotirgamaya, mrityurma amritam gamaya, which inspires us to lead from ignorance to the truth, from darkness to the light, and from death to immortality. Yes. So we welcome our dignitaries to the virtual dais. So ladies and gentlemen, we have a very interesting topic with us: influence of cognition, deep learning, and safety analytics. And we have our expert speaker, Dr. Chittaranjan, who is a director of science at with over 10 years of experience in the field. He is the author of the textbook Understanding Deep Learning Application in Rare Event Prediction. He earned his PhD in statistics from the Georgia Tech Bachelor and Masters in Industrial Engineering from IIT Kharagpur, India. He specializes in developing real-time AI systems. He is a recipient of the Best Paper Award for his research. He also serves on multiple boards of directors in the analytics and engineering space, and previously worked at JDA, Pandora Media, and eBay. So Dr. Ranjan is an active contributor to the AI community and an influencer. His publicly available content on YouTube towards data science, journal publications, and other contributions have over 500,000 readers. So the audience is privileged to have such an expert speaker with us. And I request our chairman, CoE-SEA, Professor Maiti, to formally welcome our expert speaker. Over to you, sir.
Thank you, Mom. Thank you, Dr. Chittaranjan, for accepting our request to speak on a very, very important contemporary state-of-the-art topic, confluence of deep learning, cognition, and safety analytics. In fact, Dr. Chittaranjan is our alumnus, very hard-working, very talented, innovative guy. He belongs to Jamshedpur. So I think in the Jamshedpur city, probably his house. And after that, his academics and related professional work already Mom has stated. I can only say that I am happy to work with Dr. Chittaranjan during his master's thesis. He published very good journal papers from his master thesis. And after that, when he was in Georgia Tech, we are in constant touch. And when he has written the book, he has given me a copy, and I was so pleased to see that whatever he achieved so far, he has the sky limit. So I'm sure that he will definitely make us proud every year, more and more. And Dr. Chittaranjan, so the CoE-SEA, Safety Engineering and Analytics, it's a new one, and we need your support and cooperation for its development and in future activities. I heartily welcome you for this speech. I also welcome all the participants, and I request Dr. Chittaranjan to start your speech.
Thank you so much, Professor Mathi and Mom, for your kind introduction. It is absolutely my pleasure to be here, and nostalgia hits whenever I speak to Professor Mathi. I go back more than 10 years ago when I was still there working with him at IIT Kharagpur. Everything I have learned and whatever have been able to achieve, a lot of attribution goes to Professor Mathi and the IIT Kharagpur campus. Things that I carried from there, I really carry it with myself every day, and it helps me do whatever I'm doing. Some of that I'll share with you today. Um, First of all, I want to really express my appreciation for everybody who is here today. Like Mom said, today is Dashera and Vijayadashmi in West Bengal, and also KKR is playing the final match of IPL. Despite all of that, you are here in this talk. I'm very appreciative of your uh, interest and kindness. But I'll try to keep this talk short so that we can all get back to something more interesting. Uh, Today, we are going to talk about the confluence of cognition, artificial intelligence, and safety analytics. I took the liberty of replacing deep learning with artificial intelligence. It's a little bit bigger umbrella that has deep learning within it. But for all practical purposes, it makes no difference. What I wanted to talk today is this confluence. They really interact with each other. They really impact each other. Human cognition, artificial intelligence, and safety analytics. When we go through this talk today, we'll see how artificial intelligence is used for safety analytics. Then we'll find a twist in the story and see that actually artificial intelligence itself needs some safety, and how both of them can be addressed by going back to the basic principles of how humans think, how our cognition works, to address the issues that we'll see in both 1 and 2. I'll start with this very nice quote by the authors McClelland, Rumelhart, and Hinton. Jeffrey Hinton, who is the third author here, you might know he's one of the fathers of modern deep learning. His research is pretty much everywhere, backpropagation methods, and MLP, multi-layer perceptron. Most of them are coming from his research and his partners like Rumelhart and McClelland. And they started, if you look at their first book, that book is basically a culmination of several research papers that they wrote. It was the title of that book is Parallel Distributed Processing, and it was published in Cognitive Sciences. So basically, all of this started from what people were learning from cognitive sciences and psychology. And people started to see how that can be brought into a machine, and perhaps machine can do that level of thinking for us. Before anybody could get there, the first right question that they asked to themselves was, what makes people smarter than machines? Because machines are more precise than us. They are faster than us. For example, if I tell you what is 99 times 13 times 287, it will take quite amount of time for most of us to tell what that is equal to. But for a machine, it is almost instantaneous and also accurate. Why I'm emphasizing on this accurate part? Because humans mostly work on approximations. Like if I tell you or ask you what is 99 times 11, you will say, okay, that will be close to 100 times 10, so somewhere around 1000. You'll do that approximation, and most of the things we do around us using such approximation work fine. We are okay. Humans have used this level of impreciseness and slowishness compared to machines, but they have used it to their benefit and evolved to this level. Why is it possible? How is it possible? Because we are better at perceiving objects, better at using our memory, better at weeding out noise from information, and all of this comes from our cognition, which we'll talk about and think about during this talk. And also, as we go forward in the next slides, I want to tell that I will keep this entire conversation very non-technical. This will be a storytelling. Maybe we'll meet again to go a little bit more technical, but today we will keep it very non-technical story about how things work and where we can address some of the issues. I was just talking about cognition, our cognizance, how we are able to perceive objects, gather information out of noise. And it is really very important because that helps us avoid any hazards or threats. It really keeps us safe, but only to some extent. I think we'll all agree that with whatever level of cognition we have, we still are limited, and that leads to several accidents because our capacity is limited. How machines can address such limited capacity? A very good example is if we think about a self-driving car. Where I used to live in my previous house, basically, there was a highway which I mostly would have to use when I have to go from point A to point B in the city. Basically, I will drive and then I have to merge to the highway. Now, that was a very interesting road design, and it was awful. I will dread getting into that merge because two highways will merge and then soon they will split into two directions. What it means is you will have a lot of cars merging and then diverging in a very short distance. And then when I'm merging there, and usually I have to go to the other side, I'll have to constantly look forward and backward simultaneously to make sure there is no car in front of me or behind me so that I can safely maneuver from lane to lane. And because it was highway, every car will move very fast, so I have to be very careful doing that. There, I could very vividly recognize my limitation. That limitation was I can only see in one direction at a time. I can only see forward or backward, as opposed to a self-driving car per se. Self-driving car, like shown here, has vision systems all around itself. This system can automatically and simultaneously see the entire 360 degree and make the best decision on how to maneuver the car. Basically, wherever we are limited, machines are not necessarily limited, and therefore they can work better than us. And that is the genesis of artificial intelligence. So, although humans can do a lot of things together better than machines, perhaps, but a machine can do one thing much better than a human. So, if you can train a system, a machine, to drive a car, it is very likely to do a better job than a human. So, that's how this concept of self-driving car came into being, and then a lot of research is being done to keep it safe. The hypothesis is if every car will be self-driving on the road, everybody will be more safer than they are today. So basically, this is an example of a motivation behind using AI for safety. The benefit of safety is very obvious. I will not spend too much time on that because I have also attended some of the previous talks by experts in this weekend talk. And all of them have very nicely emphasized on the importance of safety analytics, much better than I can do. So I'll just say that safety analytics is important for human lives, our health, and also for material around us. Now, I will go through a little bit on some of the recent research I have seen where artificial intelligence was used for safety analytics. Starting from the AEC industry. AEC industry is architecture, engineering, and construction, basically the construction world, which surrounds all of us. And basically, this AEC industry is one of the major economic drivers. The whole country infrastructure relies on it, but it also requires a lot of safety measurements because any mishap there causes major life-threatening issues and also costs lives sometimes. Just to bring this in context, if we look at the statistics from the US, there are more than 40% of the bridges here which are older than 50 years. And more than 9% of them are rated as structurally deficient, meaning they have structural issues. What it means is they are aging and they really require constant monitoring to ensure that it is not causing any accident. A natural approach to prevent any accident is obviously visual monitoring. Experts go to these bridges and do visual inspection and assess the safety. But naturally, this is extremely costly because many times these bridges are also in remote locations, which means that you have to bring an expert from another location, fly them to there, and then get the assessment and all. It's time consuming, very costly, and therefore it is not very often done. A solution is deep learning. There's a lot of text here. I will give you the gist of this. Deep learning was a dying science, actually. If we talk about how things were happening in 1900s and 2000s, actually there's a nice story. When I started PhD, that was 2011, the scenario was such that I was in the industrial engineering department in Georgia Tech as well. And my advisor very clearly said, if you do any research in neural networks, you're not going to get your PhD. And the, the reason was because till then, neural networks, deep learning was not even a term 10 years ago. It was mostly neural networks. And it was not taken too seriously because of several issues it had, mostly with respect to model fitting. And that was because one, the computation limitation, and second issue was overfitting issues. I'll quickly brief about them. The overfitting issue was because neural networks are big models with too many parameters, it is very easy to overfit them. And then around 2000, later part of 2010, things like dropout came into being. A dropout was a major regularization upgrade to deep learning, which made people take deep learning seriously. And then actually it was rebranded as deep learning and it became a major work area. There was another very interesting turning point that brought neural network to deep learning, which was GPUs. And it is another interesting story that GPUs was not ever made for people to do deep learning or artificial intelligence. GPUs were actually made for gamers. So this gaming world, they were gamers are very passionate, of course, and they wanted more computation because their uh, monitor will not render all the new fancy visualizations anymore. So they needed more computation, for which graphics systems started to be developed by NVIDIA, and then those graphic systems actually led to GPUs. So if we have to thank anybody for the great advancement in artificial intelligence, it is a gamer's world, which we had a different impression for when we were in IIT. Anyway, coming back to the topic here. What happened in 2010s is that deep learning became a serious subject. It was solving real problems, specifically in image recognition and object detection problem. And if you think about what I was just talking about, visual inspection of bridges, a human will go and look at the structure and cracks and those things on the bridge and will assess the structural integrity of the bridge, and basically it's from safety standpoint. That can be done using deep learning systems now because deep learning systems are very advanced in such visual processing. Another system that is an extension of what I just said, very good in image processing, that leads to video stream analytics at a large scale. Now, we want to make our cities safer. To make our cities safer, governments have installed a lot of cameras on traffic signals other places in cities, and then parking areas. Parking areas are the worst place to be during nights because they are deserted and the usual place for violence. But people are now installing video cameras there for continuous monitoring. But those monitoring systems are of little use if no one is looking at it. We have humans who constantly monitor those video feeds, but that's a lot of work for a human to see so many videos and then constantly be alert to notice any violence or any mishaps. AI systems can do it for us, but AI systems are, if you think about these systems, we are talking about a lot of data, like zettabytes of data, because video are high frequency data, and each frame in a video has so many pixels. So we are talking about a lot of processing there. If we have to do all of that in real time, it is at least right now not possible. For that, there are various ways in which people are solving it. Edge computing is one of them. In edge computing, what happens is you do the majority of the heavy duty work on the cloud, and you bring the part of the model that you need for inferencing, or you can have a downsized version of your model. There is significant research that is being done on this, which again, as I said earlier, we can talk in a future conversation, using which you can bring a heavy duty deep learning model to the edge for real-time inferencing. The use of this will be that if someone is doing any violent activity in a deserted area, let's say parking lot, then some police or some other authority can be immediately alerted. Just continuing down this route, there is another aspect to safety which is more closer and basically comes to our home. We want safety in our home and around our home as well. Of course, we want safe cities, but home will be good as well. And that is one of the concept of smart cities. For example, where I live right now, there are the doorbells have video camera in it, which is constantly seeing the activities in front of my house. And if it is seeing any movement or basically any unexpected activity, it sends an alert on my phone. This is the concept of smart home, and which requires again similar level of AI system which can perform such monitoring for safety in real time. The paper that I'm referring here is doing it for audio analysis. It calls itself a deep ear. What deep ear does is if there is a domestic violence or any other burglary or similar violence happening at home, it will catch it immediately and send alerts. Whatever I said sounds like a very good story. This is a very forward-looking approach. We have problems that are traditionally solved by humans, which can be automated using AI to make everybody safer. But here's a twist in the story that I mentioned earlier, which is these AI system itself needs safety. They are also vulnerable. An example. Now think about a self-driving car. A self-driving car is working by taking video constantly of its surrounding and making a decision. Imagine it, the car is moving and goes to an intersection, and there's a stop sign at the intersection. If there's a stop sign, the car must stop. But let me also explain what happens if it doesn't stop. Basically, stop signs are usually at intersections and cars are coming from all directions. So a car which is approaching must stop first, otherwise it will collide with some other car from another direction. So the point is stopping is necessary at a stop sign, but there is a paper called Fooling Deep Learning where it is shown that just by adding some blemishes on the stop signal, you can fool the AI system to misread the stop sign as speed limit 45. This is very interesting because as human, when you look at it, it is still stop. It still reads stop. But for an AI system, it becomes speed limit 45. And you can imagine the magnitude of problem this will create because of course the world is not perfect. There are stop signs where some miscreants would have put a paint smudge or pasted a sticker or something like this. This is very possible. I have seen it many times, stickers on stop signs. So how can we make the AI system itself safe of itself? This is a very interesting problem I want all of us to think about here, that it's great to solve safety problems using AI, but what about keeping itself safe at the first place? Another similar example, there's a panda here. This is another very nice paper which showed that simple noise was added to this panda. This noise is no information for us, which is because if you add this image plus this noise, this is the output. So this is still a panda for a human. There's no difference between left and right images. But just due to this image, this noise added, now the deep learning system misread the panda as a gibbon. This is another very good example how you can fool a system. So suppose you have a face detection system that you're using for, say, if you're looking out for some criminal and you want to do face detection. Very easily, the girl over here wore a hat which looked like this. And after that, the AI system just broke down. It could not detect the face still with a very simple hat over here. For a human, it makes no difference. But for an AI system, it no longer can work. So the bottom line that we are learning from these two scenario that I just presented, artificial intelligence for safety and safety for artificial intelligence. In the first, what we are trying to do is trying to teach an AI system mimic how a human behaves, how a human will assess a bridge for safety, and basically teach the AI system to do it for humans. And on the other side, we are seeing issues with the AI system which humans do not have, and therefore we want the AI system to also behave more closely with how humans behave by not misreading certain data, certain information like those images if simple noise is added to it. And the solution to all of this is in basic principles of human cognition. This is an example from McClelland's book. This was a very nice example. I really loved it. If you go through these different lines, what you will notice is this letter and this letter, I will read it as an H here and an A here. But in isolation, both of these letters will look the same to a machine and also to myself if I'm not looking in conjunction with these adjoining letters. But when seen together, this is H, this is A, it is the cat. Similarly, this is red, spot, fish, and dead. But this particular blemished letter is an R here, but the same blemished letter is a P here. You see, they are exactly the same. This is an E here, this is an F here. This is a D here, it is a B here. What I'm showing here is, to a human can weed out such blemishes, such noise out of the information to very precisely read what this actually meant. Because humans put context around everything. The formal definition of putting context around everything is basically looking at several constraints together, looking at multiple constraints together and solving for the answer. In this context, what it means is what comes between T and E usually. It is not an A, it is usually an edge. And similarly, how I determine that it should be an A, it should not be an edge. The interplay of this multiple sources of language that humans can very easily process is the strength of our cognition. That comes in various aspects like our perception, and in the next slide you'll see the memory. The perception component is, this might be hard to see, but these two are same noise, but this one, some of the pixels here are right shifted. When human eye looks at both of them together, it will see a circular depth here, which a machine will be unable to see, because human looks at things with a perception. And lastly, about this memory, we use memory very cleverly. Our brains know the memory that it has to keep and the memory that it has to forget. Some memory it completely forgets, but still it keeps some of the memory in subconscious, which it takes out when needed. I'll give you some real examples. A couple of weeks ago, I just got into the groove, and I thought I will make some furnitures myself. And I started with making one study table and ended with making 10 furnitures, all by myself. And I realized that I did not know how to make furniture. But when I was very young, I was a child, I saw furniture making at my home. So basically, back in India, we will have craftsmen, carpenters come to your home and make furnitures for you. So that happened at my home also, and I saw it happening as a child. Naturally, I forgot all of it. If someone would have asked me how to do carpentry, I will say I don't know it. But it stayed with me subconsciously, and when it was required, it came back to me. Why I'm telling this is human cognition is very smart in preserving memory as much as needed and using it when it finds the need. When I was writing the one chapter in my deep learning book on long and short-term memory cells, it is a type of deep learning model. There I was talking about how LSTM networks, a type of deep learning network, trains the model to preserve or forget a memory so that it is very well learned or trained to make certain predictions. There was another chapter on convolutional neural networks where I explained how humans filter data, how humans filter information given in front of them, and how a convolutional neural network mimics that approach of filtering patterns out of information to make certain inferences or predictions. The point I'm trying to make here is the models that have been built in deep learning, all of them are trying to mimic certain aspect of human cognition. It could be memory, it could be filtering patterns, or it could be deconstructing a complex problem into smaller problems and solving them and putting them together to get the final solution. What I just mentioned, they respectively refer to LSTMs or recurrent neural networks that preserves the memory. The second one I said filtering patterns, those are convolutional neural networks. And the third one, deconstructing a complex problem, that is what a multi-layer perceptron does. All of them came from those cognition, the understanding of those cognition that these pioneers of deep learning, McClelland, Zumwalt, and Hinton, who have done in their research from the 1980s. I mentioned those books here. Those are really excellent books. At the time, I'm sure they would not have seen the field to get this far. They were doing their publication in these cognition journals. If you see here, these journals are related to cognition or psychology and biological models. They all tried to mimic our cognizance and translate into machines, and they have been very successful. And this entire talk that I have today, we are at the conclusion of our talk, by the way. What I want to conclude with saying, what I want to say at conclusion is that think about this. Think about the problems we are trying to solve and the many problems that are still unsolved. And then go back to the basic principles, how humans would have solved the problem, and then get inspiration from there, put it in your models, and you'll be able to solve the problem. This has been successful so far, and this is the key to most of the research that you'll be doing in this area. Thank you so much for being here again, and I would like to take any questions if we have.
Yeah. Mom?
Yes. Thank you, sir. But I think for the audience, ye dil mange more. It was wonderful, wonderful informative lecture, sir. So I now request Souvik or Sinjana to just take up the Q&A. I see a lot of questions in the chat box.
Yeah, and not only question answer, I would also like a conversation here. So anybody here, if you want to share something you are thinking, please do it.
Yes, sir.
Open platform.
So, sir, we have collated all the questions from the chat box. So, first we will ask one by one.
Okay.
Then we will allow the participant if they want to ask you verbally.
Great.
Yes, sir.
Okay. And is this
So, the first question is, sir, what are the known solutions to handle the malfunctioning of the AI system?
A known solution is to not use AI solution. So there is a quite amount of apprehension against AI solutions, and they are rooted in exactly these kind of issues. That imagine if you take your proposal to government of India, and someone goes and tells them that a simple stop sign can be misread by an AI system. Government will obviously say the solution is don't use it. So that is a solution people are using right now, unfortunately. But of course, no one is to blame here. Now I will tell you the technical solution. This was more on the funny side of things. A few technical solutions that have worked really well is having multiple levels of decision making. So this is one thing I tell I practice when I develop solutions for manufacturing industry. So I'll take a few minutes here to explain the answer, Shavik, if that's okay. So in Process Miner, where I work right now, we are developing solutions to autonomously control, which means automatically control a manufacturing machine. It is an equivalent of self-driving cars, so basically self-driving machines. A natural apprehension there from the plant people will be, if AI is controlling my machine and something happens, who is to blame? So to prevent such a thing to happen, what we do is the AI, the decisions that AI makes are limited. By that, I mean, if you have to change the temperature or pressure of certain parts of the machine, we do not make drastic changes. It is capped, the amount of change is capped. The second level of safety is that there are multiple levels of making a decision, and some of them are very empirical decision making, kind of if else level logic that comes from subject matter expert. So what I want to highlight here is solutions are rarely complete if it is only by an AI model. A solution becomes complete when you include a subject matter expert knowledge into it. The subject matter expert knowledge or SME knowledge basically helps you add multiple layers of safety. It also helps you construct your AI model in a better manner. If you have a complex problem, an SME can tell you how to break down that problem into smaller problems and have models individually for those smaller problems and collectively use the outputs to make the final decision. So the bottom line is involve subject matter experts. SMEs can really help you make your AI safer and help you design your AI in a manner that will avoid any such untoward events.
Thank you, sir. Then the next question is, what are the reasons why any background noise fool the deep learning algorithms? While human eye is trained to ignore any noise, cannot DL model be trained like that?
Real models can be trained like that. So so that's why it is an active research area. To a great extent, real models can be trained to ignore the noise. What it is hard to do, so basically, if you know the noises in your training data, let's say you had noises in the data, so your model has learned to ignore that noise. But if someone intentionally and viciously tries to attack your AI system, that is where the challenge is. So, for example, suppose there is a group of people, a hacker kind of people, who learn that there is a facial recognition system which is looking for criminals. And to hack that system, they send some bad data to the system to confuse it. That is where the problem is, one of the problems. So basically, there is work to be done. It is an open research area that can handle such malicious attacks, as well as make the system itself agnostic to certain noise. Human brain is much more evolved. So to give you a context, a very basic difference between a human brain and a typical deep learning model. A typical deep learning model has feed-forward networks, meaning you have layer after layer stacked, and connections are between the layers. There are no connection within the layer. This is because if you make connections within the layer, training that model becomes extremely difficult. Basically, there's no approach so far to train a model which will have connections within the layer. But human brains are not like that. Human brains have connections in all possible directions. Neurons can connect with each other. It is much more advanced. Because human brains, the neural connections in human brains are multi-directional, human brains are better equipped at solving such complexity, such complex situations, which AI systems have not been able to do so far, which makes it a really interesting problem again to work on.
Yes, sir. Thank you, sir. Now, sir, the next question is, as this modeling deep learning requires huge amount of data. So now if we have some rare event model, so how can we model those rare event using DL technique?
There are, it's a very good question. Um, by the way, my book itself is on rare event prediction. So first step will be to go and read that book. And then to give a short version of the short version of answer, one approach to detect a rare event, if suppose it is so rare that you will have only one or two instances of it, suppose earthquake, it is extremely rare, then you can use anomaly detection approach. What anomaly detection does is anomaly detection only learns the normality, the normal situation, and anything which does not belong to that normal situation is an anomaly. It could be good or bad, it doesn't matter for the system. It will just tell you this is an anomaly, go and look at it. This is one way to handle a rare event prediction. Another way is using some intricate models, such as convolutional neural network. When I was solving this rare event problem and developing various models, I found convolutional neural network to work the best. Yeah, this can just go more and more technical. I don't want to go there in this talk. We can have a separate discussion on that. Shavik. But the answer is that there are multiple ways in which we can handle relevant prediction.
Yes, sir. Yes, sir. Now, sir, another question is about that. Can you put some light on safety of AI?
Say that again.
Safety of AI, sir.
Safety of AI. Uh, can you elaborate more on the question, like because we just discussed the safety of AI?
Because the question is that, like that, suppose as we are using neural network for prediction, so how can we achieve the safety of AI? Suppose we are modeling any AI-based technique, so how to মানে, confirm their safety?
Right, right. So as I said earlier, the best approach I find are again two-pronged. One is involve subject matter experts. So for example, if you are uh, trying to make traffic signals safe, then go and speak to a person who is road construction, like road, sorry, not construction, road design expert who knows how traffic work and what AI system should make decisions on, or basically predictions on. I always ask people to refrain from just getting the data and then running towards a solution using a model. That's not the best approach. Always speak with a subject matter expert. Subject matter expert will tell you how to break down your problem and where to put safety nets. That safety nets is the way to make your AI system safe. Um, the expert can tell you that if I were you, if I have to develop such a solution, I will look at the AI system output, but I'll also match it up with some other information to make sure that they are aligning. And based on this, I'll make a final decision. Like I gave the example of manufacturing system, what we learned from the expert, there's one plastic injection molding manufacturing plant. There you have several cavities of the machine which blows plastic into bottles. Now they are in close proximity. What it means is I cannot raise the temperature of one cavity to very high and its neighboring cavity to very low because heat will transfer between these two. So I have to construct my AI system such that it respects that physical limitation of a real machine. And what I have to respect here is told by an expert to me. So the bottom line here is involve an expert of the field who will tell you how things work, and you have to incorporate those information into your AI system. Never ever just take the data and start making a model. It will work for maybe a small purpose, but it does not work for good.
Thank you, sir. Now I would like to request all the participants to unmute themselves and ask their queries directly to Dr. Chitra.
Dr. Ranjan, Uday Kumar here. Yes, thanks for a very pedagogic way you explained this deep learning. It was really, I'm not an expert in this area, but some of your, like the examples you took, like as a discussion, I will tell you, cognition. There is a client model about cognition, like a long term, when you are decision making under the pressure or in emergency, and you have a long term memory is the only that works. Like if there is a fire in some building, and you have been trained how to come out. That's why we have a fire drills and also maintenance in wartime. When you are repairing under the war is going on, repairing equipment. If you have no drill, no trained, you will not be able to do it. So what you happen like is you told about the carpenters working at home, and so you bring your own memory and then you recollect and start doing. So actually we did a lot of a study on that area, how you can retrieve the long-term memory during the fire, emergency situation and all. That was a very good example how you looked at your childhood and do the job. That was. Second comments I'll give like, as you have very good explanation. And we always say like machine. I was in China, I was at Tsinghua University. I was a distinguished visiting professor there. And they are doing a lot more work on this deep learning and all. And I was talking about railway track. I work with railway, and they still we come to a workshop conclusion. Machines are going to lack the creative spark of humans for next 10 to 15 years at least. They will not get there so easily, whatever we do. Any comments you have? they said about the Chinese guys who are the sitting, the people who were in the China AI president and all were there in the meeting.
First of all, Professor Zekwan, thank you so much for sharing your thoughts and comments. What you said is so right. Those long-term muscle memory only help in under pressure situations, and it's a very good message for everybody here that build that muscle memory. It helps under such situations.
There is a client model actually. We have published also client model. It is called KLI, and client model on memory retrievals. You can. There's a book on that also. Google, if you write, you'll get it.
I'll send you a message, Professor Uday, afterwards to
Yeah,
get a link to that.
that's good.
Yeah.
And
So,
we are using a lot more this deep learning. I'm not expert, but when we are trying to develop these hybrid models for looking into the physics of failure, if system is failing, and data-driven and physics of failure based, how can we combine these two? And the deep learning and convolutional neural networks are being used by my colleague. I don't work on that, but I see the work being done by these people. This is one way to learn more. We are telling everyone that deep learning is very important to understand the system. Not only face recognition used by many companies and many ways like analyze the failure and all, but for other purposes like predictions. And we work a lot with predictive technology now. That's the future we do. Predictive and prescriptive. And deep learning will help us that. Because that's why I was curious to, and really I could make it to listen to your lectures. And you presented in a very simple examples, like a stop signs and all. Good, thanks a lot. Thank you.
Thank you, Professor Uday. Yeah, and I'll get in touch with you. And just to quickly answer your question, I know we are running out of time. So machines, AI getting creative? I don't think even I want them to be creative. I want them to do their job. Imagine if it's a self-driving car and the car becomes creative in where it has to go.
It will be a problem. Actually, I can tell you, we are working on social media for machines, where machine will be twittering to other machines, like saying on the roads, especially the cars, for the health, about health purpose, nothing else, not driving. Okay, hey, I'm feeling bad, I got more vibration. The other cars will tweet about the same. No, we all are okay, problem lies with you. And it's a European project, and we have submitted an application on that. It will be, it's moving towards that direction. The machine will be talking to machine openly.
Yeah, it is already happening, like in manufacturing field where like my professional work is in manufacturing. Their machines are already talking between themselves and making decisions. One interesting thing that happened in one of our where we did the project was that we were optimizing for one chemical, but that resulted into optimization of a very expensive raw material as a byproduct. So it was just a happenstance interesting to see.
Good. Thank you. I don't have any more comments.
Hello, this is Anima Pramanik. Actually, I'm doing PhD under my guide, Professor J. Maiti. I just have one opinion that, sir, you have already told that background noises, full deep model. Actually, if we use very old deep model, then it is true. But we can solve it, sir, in two ways. In one way, if we can use some image processing noise removal techniques for feature extraction, and then we can train the deep model using these features, then I think, sir, this problem will be solved. And in the second way, I think if we can use very ResNet 50 or ResNet 100, this kind of deep model, then I think, sir, this problem will be solved. This background noise problem. So, sir, this is my opinion. And
yeah, definitely. Thanks for sharing that, Anima.
Thank you, sir. And that's it, sir. That's it. Thank you, sir.
Yes, I would like to request Professor Obi Krishna to formally provide vote of thanks to our expert speaker today.
Thank you, Savik.
Yes, sir.
Dr. Chittaranjan, you have given very good information to, especially to me. Of course, you have given to everybody. One thing, see, we keep on talking to people, electrical safety for non-electrical engineers, mechanical safety for non-mechanical engineers, like mechanical integrity for electrical people. You have really spoken this machine learning for non-machine learning knowledgeable people like us. Very, very interesting. You have made us understand very clearly your artificial intelligence, machine learning with very common mass knowledge, non-technical things. Thank you very much. And you made my life lifelong assignment for me. In the way, all the scholars used to come to me, sir, you are subject matter expert, please give these opinions. With a lot of questions, they used to come. Almost all the scholars working for Professor Maiti, they used to come to me. Then I used to ask them, hey, why are you coming to me? If you have to come to me, then what is the research? They could never give the explanation the way you are given today. And I also did not really understand the importance of the subject matter expert in the very high technologies like artificial intelligence, machine learning. And now I understood. So my job is secured for my lifetime now. And finally, the one of the slide you have mentioned, human is still important, and whatever things keep happening because of the cognitive process of the human being, they'll always be important. Very, very important statement you have made it. Uh, I used to hear there are films also came on. Very good movie came on this artificial intelligence, machine learning. The Telugu movie came. Uh, there also they say finally a day will come. All the human cognitive processes we may include put into the robot, and you will really work like me. You will have the same thing what I am thinking. That is the fiction which they have shown. Maybe that may happen maybe in another million of years, not now. Yeah, as you very well said. I'm really thankful to you. I have a colleague, Professor Murthy. He is of 65 years, very knowledgeable in Vedas. He's a civil doctorate. Now he's writing Vedas for common people. Last 5 years he is working on that. He used to tell me, otherwise, unless I tell these Vedas to the younger generation in their own language, probably people will forget about Vedas, the importance of Vedas. Your speech on deep learning is also uh, similar to that. You have told very clearly to all the people the importance of deep learning. Definitely, we may have to have one more lecture from you. Uh, when you made in your mails that I want to keep more for the conversation, I did not really understand. Now I understood what you really meant. It's really good way of tackling the subject. So we'll look for one more lecture from you on the same work which you are doing, so that it will be more useful to all the people. Thank you very much. Uh, Thank you, Professor Maiti, for arranging such a good speaker from academics field. And my thanks to Mom, Savik, Ashish, and Sinjana, all this Bengali community. Though it is puja today, they have got into like you. They got into and spared some time. And very serious audience we have today, like Professor Uday Kumar and others, very actively participated. Though the number is less, but the quality of discussions were very good. And I thank all the audience for your very active and very important discussions. And finally, I want to tell all of you good, happy puja, good puja, and very enthusing puja. Life is coming to normal. I've seen the life is coming to normal from COVID. Oh, you're dual student. You're one man with two heads. Thank you. Enjoy. Thank you again,
Thank you.
Dr. Chittaranjan.
Thank you,
Thank
Dr.
you very much.
Chittaranjan. Thank you so much.
Thank you, Professor Ubi Krishna, for your kind message. And thank you so much, Professor Mathi, for inviting me. And really glad to have this entire audience here on the day of Puja. Happy Vijayadashmi to all of you.
Thank you.
Thank you.
Thank you very much.
Thank you, everybody. We'll meet in the next one.